it's visible for you, that's fine. Visible for you, all of you? Okay, that's fine.
Actually, I've just transferred the silicon substrate. There are some devices manufactured already. Just to show the basic working of the microscope, like how the magnification is changed and everything. I've just transferred it. So now I will try to focus it using these. These are
devices already fabricated.
Yeah, the device is already fabricated, and on top of that, metal parts are also fabricated. So you will see the metal parts.
So what is the job now?
For the current job, what we are trying to do is first we are trying to focus this microscope on the substrate so that you can see the structures. Just to make you familiar with the working of the microscope, like how these magnifications are changed and what are these dials.
Is to observe the
device on the sample.
device is already fabricated.
Yeah, no.
Only see
Yeah.
the structure.
Yeah. Exfoliation process, Shraddhan sir will come, he will show you, like he will instruct you everything. But for the meantime, I'm just making you familiar with the setup.
So actually it is not connected, so you cannot. MS will place here, and you can bring that. You can move. If you move this one, or you can move this one, it will come like this. Okay. By the heater as well as the temperature controller. This one is heater and as well as temperature controller. Okay. So if you heated the sample is heated here, and that van der Waals force will be weakened. So whenever you touch that PDMS here, it will attach and you will bring it out like upward. And microscope will help you to find that wafer that should be lifted, or you can observe the angle. How can be the angle rotated? Okay, this can be rotated.
Here the peel rate is
what happens, so there is an n number of permutation combinations which are possible, one on the top of the other to create a heterostructure. Now once you change the orientation, say, so I'm just rotating my this thing one on top of other, and if you are rotating this, so then that's a separate set of material which is formed. So that might have a different set of characteristics. Okay, so rotation is one permutation. One of the factors which you can change. Similarly, temperature, as I said, weakens the force. So obviously, based on what type of material you are using, so that temperature will cater to that.
There must be then approximately.
So normally
of graphene material.
Yeah, so 80 should be more than enough.
80 Kelvin
centigrade maximum.
Is it vacuum safe for this step?
No, see, primarily any material which is not sensitive to oxygen, which you can use here. But whenever
not vacuum enclosed, I'm asking whether that's
no, so that's what I'm saying. So whenever there is a chance of contamination, if you keep in the air, you can keep it in a glove box and operate from outside.
no, the base is vacuum.
Pump is connected here.
Okay.
If you can connect a pump here, I think here or
So there is a
I think heater.
So you can, so that is another possibility. You can put a vacuum pump so that the material stays fixed onto the holder.
Yeah,
So-
because the base substrate should not move.
Yeah, and but there is another problem for using vacuum pump. The vacuum pump transfers the vibration to the entire setup. So what you have to break the vibration by using some kind of decoupler.
Yes. So damping the vibration.
So in the previous presentation you have said like by adjusting the peeling rate we can do releasing or attaching on something. So
Yeah,
here
yeah.
since we don't have the option, how we will control the peeling rate as well as the deposition?
No, see, peeling rate and it's basically whether you lift it like this or lift it slowly. So you adjust the Z-axis now. So once so that feel has to be there. I mean, how much movement will exactly lift, how quickly. So that exact feel is there. Once you experiment with multiple materials, so then you will understand the maybe slight twisting of the Z-axis micrometer. It lifts very easily or it releases very slowly. So these kind of.
But that is possible. Like by
Yeah,
doing
yeah.
this one,
Yeah, yeah,
fill
yeah.
or you
Yeah,
can
yeah, yeah, yeah.
deposit also.
So if you Really the XY. So you move this slide holder. I think everybody you can say, for instance, if you say I can move this way, and you have to place it exactly on top of this substrate, and then you vertically to focus the layer which is on the on this particular sample holder. Okay, so then you can just, if you slightly change the focus, you will be focusing the top layer, right? Are you getting me? Now, microscope can see two distinct layers. One, if you move that, one layer will be in focus, the other layer will be not in focus, right? So now, slowly, once you bring it very closer, so then at the point of touching, you can see some kind of change in the color, exactly when the two touches, and then you can just lift off. So you can see exactly there is some color change on the screen. So you will understand that it is a lift off happening or maybe peel off happening. So these kind of things you have.
So it is a top-down approach. Top-down approach means we will be having a crystal with us, and we will be peeling layer by layer, and we are trying to make it a single layer, if possible. Not always we will be getting the single layer, but we have to repeat this mechanical exfoliation multiple times in order to get the single layer. That's why this is the process where you will lose the, where you will, even though if you get the good quality of the flakes, you will lose the size of the flakes, because since it is completely depending on your hands, how you are working with it. So if one person did, if two persons are doing the same mechanical exfoliation with the same peeling rate means if one person is peeling 5 times the tape, the other person is also peeling 5 times. But the way his hands work, the way other person's hands work will be different. So depending on that, he might get 2 single layers, he might get 10 single layers. So that we are not actually ensure the number of single layer flakes that we are getting. So that will lead you, of course, that can lead you very less number of devices in the single die. But as we know that we need to have more number of devices in the single die. So that's why they will go for growing these materials instead of exfoliating the materials. So that's where they will go for CVD and all, where they will grow the materials and they will etch it and they will make 10 or 20 number of devices based on the requirement, and they will characterize those devices whether they are working or not. So comparatively, there also we will get the quality of flakes, but there you will have control on the size of the flakes where you don't have on the mechanical exfoliation. Since just now we have seen the how to make the heterostructure, I can show you the PDMS sheet, how it looks like. So this will be your PDMS sheet. So we have to cut it based on your size. You can cut it 1 cross 1 centimeter. You can cut it, and then it will be. If you see at the edge of this PDMS sheet, it will be having 2 layers. On the top layer that you will be removing when you are sticking onto the sample or anything. There will be other layer where you have to remove it, where you have to remove it, and you have to transfer whatever material you are having. So you have to transfer first the material onto this tape. From this tape you have to transfer onto this PDMS sheet. Then you have to remove the layer which is presenting on the top of it. So that layer you need to remove very slowly, or else you will be getting bubbles or wrinkles in this PDMS sheet. Once if you get any bubble or wrinkle, then you have to throw the sheet. There is no use because your material can get damaged. Okay. Once your material is transferred onto this PDMS sheet, then you have to identify where the single layer is present in that PDMS sheet. Once you identify the single layer position, you have to cut the tape so that at last you need to have only the PDMS sheet containing single layer. The rest of the PDMS sheet you have to cut it either with the normal paper cutter or the blade you can use, and you have to cut it. So while cutting also the same thing you have to follow. There should not be any bubbles or wrinkles.
The single layers can be observed from this device.
Microscope. Everything under the microscope you have to observe and then you have to cut it. Then you can transfer it onto the silicon substrate. So like this. So right now, basically we have to choose the silicon substrate. So it will be two types, whether it is a 90 nanometer silicon substrate will be there and also 270 nanometer silicon substrate. Based on the silicon substrate which we are using, our contrast under the microscope is going to be different.
Micrometer, right? Silicon or nanometer?
Nanometer.
We have nanometer.
SiO2. Whatever the SiO2 layer will be there, maybe 90 nanometer SiO2 or 270 nanometer. These are the different. So all the crystals we will be providing whenever you buy any crystal, it will be provided in the box like this. So it will be showing as a large size HBM. So actually there is no crystal inside it because they have just normally brought the box from ISC. So like this they will provide you the crystal. So from this crystal we have to make the primary tape. So this is the graphene primary tape. So if you see that it has been taken from the Krish graphite, that is the crystal name. So the Krish graphite, we have taken the primary tape of the graphene. So it is
the sheet of graphene.
it is not the sheet, it is graphite. Still it is graphite. It is a crystal taken from Krish graphite. Okay, similarly, we'll be having the primary tapes of this is HOPG, highly oriented pyrolytic graphene. Graphite. Sorry, it's graphite. It is also crystal. So, like that, if you see the tape, I will show you the other material.
I mean, these are the exfoliations, right?
No, these are the crystals.
Crystals only.
No, crystals only. We are not at exfoliated.
This is started.
Enter, stick onto the
In
material.
that lab, I think it's going on. In that solar lab, previously we have done that.
Okay. So any neat environment you need to have to do this experiment. So this is a MOS2 material. So by looking at this tape, we cannot say whether it is MOS2 or graphene because all the crystals looks like almost a black, except HBN. HBN will be looking like a white crystal, white or grey crystal. So even observing the HBN under the microscope is also very difficult. So
You have
that's
taken
why
the sample from where?
these samples we got it from ISC. We ordered from ISC, so we got these samples from ISC. So that's why the identification of the material we need to go for the Raman characterization. Raman is the only characterization which can tell us what material it is exactly. So after transferring it onto the substrate. So once we are done with the primary tape, so you need to generate secondary, ternary, fourth tape like that. So why we need to generate these many tapes stage by stage means once you have taken the primary tape. So now you take one blank empty blue tape, you stick onto the primary tape and you start doing exfoliation. So once you stick on this is empty initially. Empty, we kept it on primary tape and it's our wish in what way we are going to do the exfoliation. So basically like this we have to make the exfoliation multiple times. It's like one crystal at a time you are putting in one place and you are peeling it. So that means that crystal will be separated in these two places. So like that you have to do the repeated exfoliation so that your whole crystal, whatever you have taken from primary tape, is going to distribute over the secondary. But still it is a large crystal only. So that's why we make another tape which has to be taken from this tape. So like that we need to make 3-4 tapes depending on that. So once you have prepared the secondary tape, you transfer onto the substrate, you observe that you are not getting any single layer. That means your tape is having all the crystals. Still your tape is having the larger crystals. So you need to minimize it. So that's why we have to again go for the third
Repeat the process of
repeat the
that.
process for the third time and you have to make it.
When
less
we are using
crystals.
addition, this whole process, just addition.
Addition is coming from the tape.
Yes, I'm just saying that we are using addition only. Addition.
This it's all completely. That's why I told it depends on how the people
Yeah.
how the people will do the peeling. Peeling means it's just this is known as the peeling. spinning
How
on.
anyone perfect in that feeling? It's like and it comes
So that comes from practice.
practice.
This is completely. That's why these are not. This can be useful for research purpose, but still, people are using CBD grown only for the research purpose also. Not get contaminated. So the actual process of making this exfoliation starts from this cleaning process of the substrate. So first we need to clean the substrate. So there will be two process. One is RCA cleaning process. The other one is standard silicone cleaning process. That is a solvent cleaning process. So in that solvent cleaning, first we will use the acetone, and then followed by IPA, then DI water. We will use it. So here, whenever we are doing experiment, the time is very important. The time and temperature at which we are working. So acetone for 5 minutes they will do, and DI for IPA for 2 minutes. They will sonicate it, and DI just they will dip it in the DI water without any sonication. Then after that we need to blow with nitrogen gun. So then the surface of this silicone substrate will be clean. Then we can start the exfoliation process, that is transferring, as I told, that peeling, and then you can transfer it onto the substrate. So once the flakes are transferred onto the substrate, you can identify in the microscope. So if you take any microscope, there will be two tuning options. One will be the coarser and the other one will be the fine. Okay. So always, since this is a direct, single-ended direct, so here you don't have any problem. But whenever you are having a multiple lens or objective lens of the microscope, then there will be screws always present around the chuck of the microscope. So at that time, you need to be very careful whenever we are moving this cursor. Your lens should not touch with any screw, or it should not touch with the sample. So first, the clarity you will get it from this cursor only. Once you see the blur image of the sample using this cursor, then you can use the fine button to get the clear image. Take you from this blue tape. So not only blue tape, if even whatever the tape you will use it, you will obviously get the residue of the tape. That you have to remove it with acetone after completion of your exfoliation process.
Acetone means like, will you dip the substrate?
Yeah, we have to dip the substrate. We are not supposed to sonicate. Once you sonicate, the thermal vibrations can remove the flakes present on the substrate.
You just dip it and
You just dip it and you can take it after 5 to 10 minutes, and you can blow it with nitrogen. So we are observing some blue colored flakes, some orange colored flakes, grey colored flakes. Okay, so this will come depending on your layer thickness. If your layer thickness is more, the more light it won't allow to transmit, so that depending on optical contrast of the layer also, the color of the flakes will be changed. Okay, single layer flake you want to identify, always your single layer will be almost, it will be like invisible. That means the single layer will be mixing with the background color of the substrate, whatever you are having. So that's why it's very difficult to identify the single layer, but this is how your flakes will look like onto the silicone substrate after you transfer. So you can focus on this particular flake.
मैक्सिमम मैग्निफिकेशन कितना है इसका?
Its magnification is
मैक्सिमम
4x after doing expansion. So this is how basically the material, whatever the material from the primary tape, we will take it and we will make the multiple tapes. Then we can transfer onto the silicone substrate. So you need to spend a lot of time to identify where the single layers are present. So same area, we used to call it as islands. So first you need to figure it out the islands, then you can search for the single flakes in each island. So that's why it is, it will give you a better quality, but it will give you the less size. As you see, the size of the flakes are also non-uniform. So if you want to make it uniform, then we have to pattern it in the rectangular form. Then you have to go for etching. Then we have to etch it out. Then only this non-uniform flakes will come into the rectangular shape. Uniform flakes. So there will be many methods. This is simply a mechanical exfoliation method, but there will be liquid exfoliation method, then chemical exfoliation method. But all those will be having a more number of residues compared to this, because they will be using the solvents and that can create more residue. Because once any residue it will dry onto the silicon substrate, then it is very difficult to remove it from the silicon substrate. And if you want to improve the size of the flakes, you can go for heated exfoliation method. Basically, for the graphene, if you are looking into that, if you want to increase the quality and size of the flakes, then you can heat the graphene substrate. You stick the blue tape onto the silicon substrate. Then you heat it up to 100 to 110 degrees Celsius for 10 minutes. That can give you the better quality and also bigger size of the flakes. But that can give you more residue also. So always, if you want to increase one thing, then you have to compromise with the other. This is the exfoliation process. Thank you.
After this, can you do metallization or what?
No. After this, basically we will go for patterning. Then we will go for metal deposition. Then the lift off will come. After lifting off, ultimately, I think initially he showed that device pattern how it will be.
Can you simply show one exploration? It's like simple or whatever the features is.
Means
Just want to, you just explain now. You just can show how to do like just a simple rough process. So this is a blue tape. No? We have to cut 2-3 pieces from there.
basically we can
Like
light it up to sample size. So our silicon
one cross one you can see.
one process.
You can do. Okay.
But you are not supposed to touch with hands. Actually, you need to use the tweezers and all. So this is the covering tape. So once you are doing anything, you just need to place the tape, because once you transfer, you need to again close it. Maybe close it with the tape. So this one also, since it is secondary tape, I am opening because I can make at any time the secondary tape. So just for demonstration purpose, I open this secondary tape. This is the piston. Whenever you just pinch it, you just need to press 2-3 times.
You have carbonate also, what are the materials?
We just you can see that material is transferred onto this board. So now you can do this repeated peeling. Okay. Now this is distributed throughout the sample. This is your substrate, then you have to place it.
Any substrate,
Any substrate. Yeah. So you can do this so that it will stick onto your substrate. Then you can press simply 2 times, 2 to 3 times.
it is transferred.
Yeah, it will be transferred. You can see some mark on that area. Like here this portion. Here the heating temperature will be different.
Just simply using hot plate.
Yeah, it's just using hot plate to be heat.
From here
Now
we'll
we
begin
can see
assembly.
also some layers, no?
Yeah, glass slide it will be difficult. Okay. That's why I showed the silicon substrate
So
directly.
simply we have to mount it.
Then we have to mount it and we can keep it. This is simply an exfoliation. This is simply mechanical exfoliation process.
And now we have to like pattern the electrodes and
Then you can go for electron beam lithography.
metallization.
E-beam lithography, you can use it, you can pattern, then you can.
EBM.
Here is very difficult. So here it will be there in the CRL, but
It's working here.
no, it's not. This is
Right
down.
now is not working.